Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on sex determination. Now, in my lecture on structure of DNA step by step, we had learned that the chromosomes are made up of DNA and histone protein. So the DNA and the histone protein together, they are known as chromatin. So we can say the chromosomes are made up of chromatin material. Now here in this figure, this is the normal chromosome. The normal chromosome, that means the chromosome is in a resting position. For example, our body is made of trillions of cells. So in all the cells, the chromosome is present like this. It is having the single chromatid. Okay, this is the single chromatid it is having. But when this cell are dividing, that time the DNA replication take place during the synthetic phase of the cell cycle, so that whatever the DNA material is there in this chromosome, that DNA material double ups, and from this double DNA two chromatid are formed. For example, over here this one is one chromatid and another chromatid is there. So this chromatid is now known as sister chromatid. So now during the cell division, the chromosomes are duplicated and they are having two chromatid. Now as you can see in the chromosome, the centromere is present. So we can say that a sister chromatid has at least one pinching region. For example, this one is a pinching region, and this pinching region is known as centromere. And what is the function of this centromere? So the centromere provide attachment site for microtubules. When the chromosomes are separating in two daughter nuclei at the time of cell division. Okay, now we are moving to the type of the chromosome. Now in eukaryotic cell, four type of chromosomes are present. Okay, and these types are based on the position of centromere. For example, in this figure, as you can see, there are four types of chromosome: metacentric, submetacentric, acrocentric, and the telocentric. But one thing that we have to note that in humans, telocentric chromosomes are absent. So the telocentric chromosomes are not seen in human cell. Now we are moving forward. Okay. Now in humans, there are 46 chromosomes. That means 23 pairs of chromosomes. And from this 23 pairs of chromosome, 22 pairs of chromosomes are perfectly matched in both males and females, and these 22 pairs are known as the autosome. And the remaining pair, that is the last pair or the 23rd pair of the chromosome, is known as sex chromosome. So in females, 23rd pair is XX chromosome, and in males in 23rd pair there are XY chromosomes. Now the arrangement of this chromosome, so now you need to remember this term, that is the karyotype. So what is a karyotype? Now karyotype is a photograph which is showing the arrangement of 23 pairs of chromosome. Okay, once again, karyotype is a photograph which is showing the arrangement of 23 pairs of chromosome of a single human cell. So now I am showing you the karyotype of men, for example, in this figure. Okay, this is the karyotype of men. As you can see, this is 1 2 3 1 2 3 4 5. Okay, numbering is given to all the pair, and the last, in men, X and Y chromosomes are present. Okay, and in case of female, in the last pair there is XX chromosome. So this XX in female and XY in male, they are known as the sex chromosome, and this remaining 22 pair of chromosome which are same in man and woman, these 22 pair are known as the autosomes. Now, so this is the karyotype of man and woman. Okay, now I am showing you one important table. This is very important table. You need to prepare this table. Okay, in this table what is done, that all the chromosome of 23 pair, they are divided into metacentric, submetacentric or acrocentric based on the position of the centromere. For example, here in this karyotype, if you closely observe, 1 2 3 4 5, these numbers are given, 6 7 8 8 9 10. So basically we are trying to identify the type of chromosome which are present in human karyotype. So with this table you can learn all the chromosomes which are present in human cell. So we have divided the 23 pairs of chromosome like this. For example, group A. So in group A, chromosome number 1 to 3 and total pairs 3. So pair number 1, 2 and 3. Okay, so these 3 pairs are the largest metacentric. So once again, for example, over here, okay, 1 2 3 and A is written. Okay, so there are 3 pairs. So now you understand. So group A, there are 3 pairs and the type of chromosome, so largest metacentric. Then group B, there are 2 pairs, pair number 4 and 5. Okay, for example here 4 and 5. So 4 and 5, they are largest submetacentric. Okay, so the description of all the pairs, you can go through this and you can prepare this. Okay, now the important point I am showing you so that you can prepare your notes. Okay, this way. Okay, and now you note that the last pair, okay, group here, for example, group H, this one, okay, the 23rd pair, okay. And what is written in female? As we know, there are two X chromosomes, okay, and this X chromosome, they belong to C group. And what is the C group? So medium size submetacentric, okay. So in women's, we can say that there are two medium size submetacentric chromosomes are present in 23rd pair. That is the meaning of this thing, okay. And in men, okay, one X chromosome that belongs to group C, and one chromosome is a Y chromosome, okay. So Y chromosome similar to G group chromosome, and the G group chromosome, so G group is a small size acrocentric. So I am showing you this X and Y chromosome, okay. As you can see, this is the small size acrocentric Y chromosome, and this is the submetacentric X chromosome. So in females there are two X chromosomes, and in men X and Y chromosomes are present in 23rd pair, okay. So these are all the, this one is the karyotype, okay, karyotype of a man. Different figure. This is also an important table for you, okay. Human and Drosophila, female XX, male XY. In bird, there is ZW, ZZ. Then grasshopper XX, and male is XO. Honeybee, diploid and haploid, female and male. Okay, okay. This is the take home message, and this message is for you, okay. You go through this, you prepare your notes, okay. Some more take home message for you. All this detail you need to go through, and you need to prepare your notes, okay. Now this one is also a karyotype, okay, 22 pair, and then this one is the last XY. So this is the male karyotype, okay. Here it is written human karyotype. Now coming on the main discussion of our today's lecture. Now we have studied the process of oogenesis. For example, in oogenesis we have started with oogonium. So oogonium, then from mitotic cell division primary oocyte is formed, and secondary oocyte, and the first polar body. Now we know that in the Graafian follicle, when the Graafian follicle ruptures, by that time this primary oocyte completes meiosis 1 and 2 cells are produced, secondary oocyte and the first polar body. We have learned this, okay. Now this secondary oocyte is not completing meiosis 2 until when it is joined by spermatozoa. So when the sperms, they are approaching this secondary oocyte, so at the time of fertilization, this secondary oocyte will complete meiosis 2, and that time it is converted into an ovum. So in this ovum, there will be only one sex chromosome, and that will be X chromosome. Okay, and here this is the chart of spermatogenesis. We have already discussed this process also. Okay, so we had started with spermatogonium, then we are having primary spermatocyte, then from primary spermatocyte, then the secondary spermatocyte, then the spermatid, and spermatid, they are transformed into the sperm. So in this spermatozoa or the sperm, there are 22 autosomes. Then there will be sex chromosome Y, and here in ovum there will be 22 autosome, and last chromosome, that is the sex chromosome, is X. Okay, so here in this figure, for example, in this figure, as you can see, father and mother are shown. Okay, and XY is written. So you need to understand, in fathers all the body cell, there are, in all the body cell there are 22 pair of autosome. Okay, and 23rd pair 23rd pair is having XY chromosome. Now when the spermatozoa are produced, that time, so this cell, all the cell, they are having 46 chromosome, and by the time of spermatozoa formation, due to the meiosis process, the sperms are having 22 autosome plus Y, one sex chromosome, and the female or the mother, she is having 22 pair of autosome, and last pair is XX in all her body cell except the egg. So in egg there are 22 plus X chromosome, and in sperm there are 22 plus X or 22 plus Y. So if sperm is having 32 plus X chromosome, and in ovum there is 22 plus X, so when the zygote is formed, in the zygote there will be 44 plus XX. Okay, so from that zygote we know the cleavage will occur, then the morula, then the blastocyst stage, then the implantation, pregnancy. So in 9-month pregnancy, the baby girl's body will develop, and mother will give birth to girl child. Okay, now if father's sperm is having 22 plus Y chromosome, and in ovum there is 22 plus X, so this sperm and this ovum, okay, this sperm is fertilizing this ovum, so by that time in the zygote there will be two sets of chromosome, that is 44 plus XY. Okay, so again, cleavage, morula, blastocyst, implantation, pregnancy. So after 9-month pregnancy, this time mother will give birth to baby boy. Okay, so now we can say the chances of that the pregnant mother will give birth to boy or girl, that chances are 50-50. So it is like a tossing of coin. So if you toss a coin, then the head can come, and if you toss the coin, and you can get the tail. So if you are tossing 1000 times, then there are probability, I'm saying the probability, 500 head and 500 tail you can get. So here also there is a probability that the 50%, there is a probability that the pregnant woman will give birth to baby boy, or 50% chances that she will give birth to baby girl. So as you can see, in woman's ova there are always X chromosome are present, and the spermatozoa, they are two type. Okay, so this X chromosome which is present in spermatozoa, this is the sex chromosome, and this sperm is fertilizing the ova, so we know the boy is going to born. Oh sorry, this is the X chromosome and this is the X chromosome, so we can say the baby girl is going to born. Okay, and this sperm and this ova, if they are taking in the process of fertilization, so the zygote is going to prepare, and in the zygote there are XY chromosome, so we can say the baby boy is going to born. So now the sex determination, who is determining the sex of the child? So it is the father's spermatozoa. Okay, father's sperm is determining whether in father's sperm there is a X chromosome or Y chromosome. That thing is determining the baby is going to be a boy or girl. So mother is not responsible for giving a birth for boy or girl. Okay, so all this thing, you need to understand, you have to remember these points. This, so you need to prepare these points. I have already explained these points. Okay, you go through this point and you prepare your notes. So now then this thing we have discussed, then this is also very important. Okay, by this chart you can understand. Okay, meiosis. So in oocyte there is always XX chromosome, and here in the sperm production, so in the sperm there is either X or Y. Okay, so XX female, XY male, XX female, XY male. So there are 50-50 chances of boy or girl. Okay, these are the possible combination. Then this chart. Okay, then this thing. Okay, how the zygote is formed. In the process of oogenesis we have discussed all this thing. Okay, so I am not discussing this thing again. Then this is also important for you, you can go through this all information. Okay, so with this I have completed the presentation lecture on sex determination. I hope you have enjoyed this presentation lecture. My name is Manish Kosti sir. I am from Ahmedabad, India. Bye bye. Namaste.